Hello, you are welcome to this channel, Research Plus. In this channel, I provide you with AI approaches to research analysis, interpretation, and reporting. If this is your first time of coming to this channel, please subscribe to this channel, and anytime I come up with new quality content video like this, you'll be the first person to be notified. Thank you. Let's take our today's class, and God bless you. Welcome to class today, and in our today's tutorial class, I am going to teach you how to interpret your ordinal regression analysis and report it in your dissertation. So sit down, watch exactly what I'm about to do, so that you can effectively interpret your ordinal regression analysis. So in ordinal regression analysis, there are tables that this analysis will come up with it. From my right hand side, you will see ordinal regression, you see case processing summary, you will see modern fitting information, you will see goodness of fit, you will see pseudo R square table, you will see parameter estimates, you will see test of parallel lines. If you are familiar with multiple linear regression analysis, you will agree with me that what is called parameter estimate in our multiple linear regression is what we call coefficient table. Then when it is this pseudo R square in our multiple linear regression is what we call modern summary, where you will see your R square. Then you will see goodness of fit. In goodness of fit, when you go to multiple linear regression, it is what we call ANOVA table. So sit down as I carry you through the process of interpreting this result. So you come back to the left hand side, you will see what I have prepared in MS Word, though all of them are MS Word, because I have imported this one from SPSS database so that I can run this tutorial class with it. So you will see modern fitting. What is the point of interest? In this modern fitting table, this one that you are seeing, what is your interest in this table and what are you going to interpret? The first thing that you are to interpret is to check the significance level or significance value. And you are going to make a decision based on that. Then on this particular modern fitting table, there are two things: intercept only and final. What does this thing mean? The first one, intercept only, means that model without predictor. Model without the predictor is intercept only. Then final. Final is when you introduce the predictor to the model. Then you will see final. You will see chi-square. You will see a difference table. So these are things, but the most of what you are to consider is your p-value, and whether the p-value is less than 0.05 or it is greater than 0.05. So on this case, on this very data that we are seeing, the p-value is less than 0.05, And by the hypothesis that guide this table, it says that if the Newton hypothesis state that the data is fixed for the analysis, what it simply means is that if we have a p-value that is less than 0.05, it means that this model is fixed for our analysis. And because of that, we are now going to say that this model is fixed for our data. So that is how you are going to present it. You now says if the p-value is significant, it means that the model fits the data well. But if the p-value is not significant, that is greater than 0.05, it means that the model does not fit. So on the case of this, we are reporting that our model fitting information, the p-value is significant. Therefore, our model is fit for this data. The next thing we are going to take is the goodness of fit table. What is our point of interest? What are we reporting? Just like I have said, the interest is also on a significance value. So on the case of goodness of fit, for this table to be relevant as we are reporting it, the table has not to be significance. It has not to be significant. So we have a chi-square value, which is person, and we also have deviant, which is what is in the goodness of fit table. But what I will want you, as you are reporting, so when you are reporting goodness of fit table, just like I told you, your interest is on the p-value. But this is how the statement is going to come like. You will now say that the degree of freedom, you code the degree of freedom, which is 3158. While the chi-square, you code the value of this chi-square, which is 3252.59. Then you code this value and state, you code that the significance value, you state the significant value 0.118, which is greater than 0.05. On the case of goodness of fit table, the table has not to be significant, because if the table is significant, it simply means that the data does not fit this model. But if the table is insignificant, it simply means that the data is fixed. So it is an opposite of the model fitting information, where that of the model fitting information has to be significant, while goodness of fit has not to be significant. So mind you, that is what you are going to report. You are reporting the p-value for the goodness of fit if it is less or greater than. So the next table that you are reporting is what we call pseudo R-square. And I said that pseudo R-square is equivalent to what we call modern summary in our multiple linear regression. And when it comes to pseudo R-square, what does it mean? What it means, for instance, if in our modern summary in multiple linear regression, let's assume that your R-square is 0.45, and we know that we are reporting it in percentage. So, and I say if our R-square value in a multiple linear regression is 0.45, what does it mean? It means that 45% of variability in the dependent variable is accounted for by the combined effect of the independent variable. So that is exactly what is obtainable in multiple linear regression. So in ordinal regression, of which we are reporting now, we have an equivalent of that which is called pseudos R-square. And in pseudos R-square, we have Cox and Snee, we have NAC-Ricketts, we have Murphy. So there is no standard that is attached that you must use this one to report. But I guess the mostly used figure is the NAC-Ricketts. So by implications, what it means is that you are going to report for these ones, we have 48. So we're now going to say, to make a statement, that our pseudos R-square value, we will say that our pseudos R-square value, which is 48.3, we now say 48.3% of the variability in the dependent variable is caused as a result of the combined effect of the independent variable. So you know your independent variable. On the case of this table that you are seeing, our independent variable is the 21st century church. This is the independent variable for this data that you are seeing. So what this pseudos R-square simply means is that 43.3% of variability in the dependent variable is accounted for by the combined effect of the independent variable. You state the NAC-Ricketts value that you are taking your decision on it. So if you report it that way, and that is the interpretation, and that is how you are going to report it. So having done that, the next one that we are going to look, which is the most interesting part of this interpretation and reporting, so it's called parameter estimate. And I told you that parameter estimate in ordinal regression is what is termed as coefficient table in multiple linear regression. So this is the parameter estimate. You will see it. You will see upper one is the dependent variable. Then the lower one is the independent variable. For this case, we have we have a passive end time prophecy. We have denomination. We have personal religious belief, and we have convenient access to church. So these are 4 independent variables that we are going to see and take the effect. But before I say anything here, let us look at the interpretation. So I will want you to concentrate on the estimate. Look at this table. Look at the estimate columns. This is the estimate columns. And the value that you are seeing here is the estimate, but we can find the odd. We can find the odd of this estimate, because that is what we are going to use in reporting this or in interpreting and reporting this report in our dissertation writing. So let me make a clear explanation on what is our areas of interest and how you are going to report it. So like I said, like other table, when we come to parameter estimate table, that is where our interest is most there. And what is our point of interest? One is the significance value. We will focus on significance value. And secondly, we are going to focus on the estimate value, which is odd. We call it alt value because that is what we are going to use, and that is where our interest is. So there are times that you will now take this column. This is your p-value, and this place is your estimate, which is the alt. So there are times that you will now see that your estimate has a negative value. It has a negative sign attached to this one. Like this one is 0.390. In some cases, you will get minus 0.390. That is what it means. Then you will have instances like that. But for these ones that we are dealing with, there is none that have a negative sign. But look at our p-value that is attached. We have 0.053, we have 0.174, we have 0.00, and we have 0.002. So, decision rule. Let me say something about decision rule as you are going to interpret this result of your parameter estimate. One, if our estimate value has a negative sign attached to it, e.g., minus 0.21. Thus, this is how you are going to interpret it. You are going to say, for every, okay, you will first tell us the significance level. Okay, for these ones now, we are assuming that this is the value that we are dealing with. The first one, passive end time, passive end. And let's say the value that we are getting for the passive end is not this 0.390, but it is minus 0.21 as it is shown in this example that I'm giving you. So you are going to tell us whether this value is significant. It is not significant. So it is more than 0.05. So I'm going to make a statement like this. I will now say passive end time has not significantly positive contributed to the dependent variable. If I make the statement passive end time prophecy has not significantly positively contributed to my independent variable, I will now put comma. Then the next statement I will follow is that for every 1 unit decrease on the IV, which is my independent variable, there is a predicted decrease of minus 0.21 in the low odds of falling at a higher level of our dependent variable, which is 21st century church. That is on the case that we have a negative sign. So now let me use these ones, personal religious belief, as an example, which have a p-value of 0.00. So I am going to make a statement like this. I will now say that personal religious belief have significantly and positively, contributed to my dependent variable. Command. I will now say, for every 1 unit increase in my IV, which is the independent variable personal religious belief, there is a predicted increase of 0.950 in the lower odd of falling at a higher level of my dependent variable. And that is how you are going to interpret the result of your findings when it comes to parameter estimate. So if you are going to look for the odd, the actual odd, because this one is the estimate, you can look for, you can go and calculate that in our Excel sheet using exponents. You can copy this one, copy this table, you take it to Excel, and you enter a formula equals to EXP, you open bracket, you enter this value, and you press enter, then it will calculate the odd for this one. So instead of quoting the estimate direct, you are going to quote the real odd of that estimate in reflecting on your interpretations of your findings. So it is this place that if you have done it successfully, it means that you have reported, you have interpreted your work correct, and you have reported it correct. So you are going to do it one by one. So as a matter of emphasis, you have to report two things altogether. You are reporting the p-value, you are reporting the estimate, which is the odd. So when you are reporting the odd, you will tell us, when you are reporting the p-value, you will tell us whether the p-value has contributed positively to our dependent variable. Then you are now going to tell us what it means by the value of the odd. So by the time you interpret it this way, then we are okay with you. So the next thing that we are going to take, because when you run an ordinal regression, this test of parallel line will appear. So when we come to the interpretation, what is this test of parallel line? You will see model where it is written non-hypothesis, and you will see general. We are going to compare two things. It's just like what I have told you from the beginning here, where we have compared the intercept only and the final. Where we say the intercept only is just the model without the predictor, and when final is when we introduce the predictor. So in this test of parallel line, we are going to compare this non-hypothesis and the general. So what is this non-hypothesis on this table? This is the baseline table model, and it might assume that the data points represent parallel lines. That shows that our distribution is in a parallel line. Then there is a model again, which is general. This is the second model being tested, and it likely allows for more complex relationship than just a parallel line. So we are saying that we are going to compare the known hypothesis and the general to see what actually it means. So we also have what we call two-log likelihood. You will see it on the parallel line table. What does this mean? This is a statistical measure used to assess how well a model fits the data. Lower value indicates a better fit. In this case, the general model, you will now code the value that you are seeing there, which is 931.773, has a lower two-log likelihood value as compared to the known hypothesis. When you look at the known hypothesis for this, you will now see that we have 935.776, which is greater than the general. So it suggests, it means that it means it suggests it suggests that the model is fit for the data. So the next thing you are going to see is the chi-square. What is this chi-square? This is another statistical measure used to assess the differences between the two models. A higher chi-square, which indicates a larger difference between the model. Here the chi-square value is 4.003. So we also have what we call the degree of freedom. This stands for the degree of freedom, which is a technical term related to the number of independent pieces of information in the data used for the test. In this case, the degree of freedom value is 64. So as you can see it here. Then we also have our significance value, which is C. This is the p-value, which represents the probability of observing a chi-square value this high, assuming the Num hypothesis is true. In this case, the sim value is 1.00, which is a very high. So on this one, we will now say that this table, the p-value is not significant. So then how are we interpreting it? In a general model, this is how we are going to interpret. In a general model has a lower 2 log likelihood value, suggesting it better fits the data. The chi-square value is relatively small, which is 4.003, indicating there might not be a very large difference between the model, which is true. Then the last one, however, the high p-value, which is p equals to 1.00, makes it difficult for us to reject the Num hypothesis statistically. In a simpler terms, the evidence for the general model being significantly better is not conclusive based on this test. So, just like I told you, the p-value is not significant. It's supposed to be significant if we will now say that the data is not parallel, but it has spread across. So by the time you have interpreted your ordinal regression to this particular point, I believe that at this point most of the researchers we agree with you on based on what you are reporting. So thank you so much. Have a wonderful research. Have a wonderful time. If this is your first time of coming to this channel, please subscribe to this channel as a way of encouraging me, and like it so that we can create a greater impact in the community of our modern researchers. Before I end this video, I want to acknowledge my professor, Professor Sila Danjuma, the Provost Elelion Bible College and Seminary, Karo, Nigeria. He is the brain behind who I am and what I am doing in this tutorial classes now. I thank you so much. May God increase you. May your work never ended like that. And let's always be sensitive as we run our data analysis. Thank you, and God bless you once again. Bye-bye till we meet in our next tutorial, where I'm going to talk to you on how